Alright, this is our tap handle project. This is the main page, which kind of shows the overlay of all the different components that make up the tap handle. There's 5 components that go to it. You have a main body, a handle, 2 jaws, and a collar. What we're going to focus on today is making the main body of this. The material we're making the main body and the collar out of is called stress proof. It's an 1144 material that has a proprietary heat treatment process to make it. It's a pre-hardened material, but it cuts good and it doesn't warp very much when we cut it. So looking at this, this of course is the main page. This kind of shows us how it goes together. This next page actually shows us the detail on the collar. What I'm going to observe first of all on this is the actual diameter of it is 927, which is a 15/16 diameter. It's going to be hard to find that size material, so we're going to make it out of 1-inch stock. The second thing I notice is the way that the part is orientated would actually be not correct for proper manufacturing technique on this. We want to take the part and completely turn it around so it's facing the other way. So the angle on the nose of the part should be on the right hand side. What that will do, with proper planning, we can set up our piece of bar stock in the chuck and we can machine almost all of the features on this part in one setup. Then we part it off, and what that does is it ensures that there's concentricity between the different features of the part. The material, 1144, has a cutting speed for high-speed steel of about 70 surface feet per minute. Looking at the diameter, this is roughly 1 inch, and that's what we're going to start with, 1-inch material. If we multiply it, 4 times 70 gives us 280, and then we can multiply that from between 3 to 4 times to get our speed that we're going to run carbide at. That puts us roughly between 840 and 1120 RPM. So that's kind of your range, and with our modern carbides, they do have some variation as to how fast we can run them. Some of it's just a try before we make a decision. So I'm going to go ahead and speculate that between the 3 times and 4 times is about 1,000 RPMs, which corresponds nicely to the speeds on my lathe. So that's what I'm going to use, is 1,000 RPM to peel off the outside diameter of this. And then I'm going to use about the same speed to cut the relief here. It goes down to a 822 diameter. And then over here it has a relief that takes it about a 777 diameter. I'm going to do the entire outside diameter, this smaller diameter, this relief diameter, and then I'm going to put the taper on it. After that's all completed, we will then take it and either cut or part off, probably cut off with the saw, this back end of the part. After that's completed, we can then hold the part in a collet and clean this back edge off, back side. The reason we are not going to thread the part on the first setup is, if you look, it has a large slot cut right through the nose of the part. That is going to require us to hold this in a 5C collet block and hold it extremely firmly. That's going to be a very high pressure cut right there. If we hold it in a collet block, we can hold it with a 15/16 collet on this 15/16 diameter. That'll give us some pretty good strength and rigidity to be able to slot that. However, if I go and I thread this portion of it first, and then I try to clamp over that threaded portion with a 5C collet, I'm potentially not going to get as much traction on the part, first of all, because not nearly as much surface contact, but I can also have a tendency to damage the threads a little bit. So our order of operations to complete this: we're going to hold the bar stock. The part is going to be turned the other direction. Hold it in a 3-jaw chuck, peel down the outside diameter, peel this nose. Of course we have to face it. Going to cut this relief cut, and then I'm going to taper it, put this taper on here. Now I forgot to mention, after we, before we even start any of these other features, we're going to go ahead and face this off and center drill it so that we can keep a live center into this part while we're doing these other operations. So let me revise that. Order of operations: face and center, peel down the diameter, cut my relief here, or cut it to 822 diameter, then cut my relief diameter here of 777. Then I'm going to cut the 15.5 degree angle. Then I'm going to come back here and I'm going to cut the part off, flip it around, hold it in a collet, and then I'm going to face that off to make it nice and smooth. At that point, if I choose, I can go ahead and polish this part very finely, and I probably will. I want the nose to look nice and smooth and clean, but after I cut the slot through there, it's going to be very hard to polish it. One last feature that does need to be noted on this part before we part it off is we look over here to the far left. It shows that there is a .438 diameter hole, or a 7/16 for all practical purposes, drilled 2 inches and 100 thousandths deep into the part. We will do that as our last operation before we cut this part off. And let's get started.